Today, I'm helping you find the uncertainty of a velocity where it's not based on direct measurement. Here is some data for an experiment from a student in grade 12. What they did, they dropped a magnet through a coil of wire with electricity running through it. As more electricity runs through it, this magnet actually falls in slow motion. It's very, very cool. And so their independent variable was changing the current and measuring time to fall, and then they calculated the velocity. Just like in your experiment, you might be measuring something and then also wanting to calculate the velocity. They have 5 trials because they're in DP. You may only have 3 trials. That's okay. The average is the same. You know how to do that. So one thing that some of you may have done in grade 9 already or earlier this year is finding the uncertainty for repeated measurements. So we're going to find here the uncertainty for time. The symbol for this would be delta t. On a map is option J for the delta sign. And the symbol for this will be seconds. Okay. To find the uncertainty for time, we need to find the highest value, the lowest value, and that's the range. The uncertainty is the average to the highest or the average to the lowest. So we got to find the maximum, the minimum, and divide that by 2. Fortunately, the computer will do that for us automatically. So we know O equals, and have open brackets. Then to find the maximum, we're going to type the word max, and we click on max. It's a function, and it changes to capital. And we tell it we want to find the maximum of these 5 values. For you, it's probably only 3 values. Close brackets, so that gets the maximum, minus the minimum. That's going to be, we type the word min, click on this, and then we select the minimum of the same thing, close brackets to finish the minimum. Then we need to have one more close brackets for this one here. You can see the shading. Then we see divide by 2. And that gets us the uncertainty, for time. You can click the little check mark or just fill down yourself. That part you may have done before. It's this next part, which is new. The uncertainty for velocity. Velocity is distance divided by time. So first let's calculate velocity. Velocity, and in this case it fell, our symbol for was V, it fell 14.7 centimeters, so our units may be centimeters. That's okay, so it's going to be centimeters per second. Okay, and this was measured at 14.7 centimeters with a certainty of 0.1 centimeters. So the distance equals the distance, 14.7, divided by the time, which is this average time, and then fill down, yes, we want that. You probably will get it with more decimal places, something like that. I did something earlier, so I already controlled my decimal places. Let's just delete some of these things. Actually, no, I won't. Yes, I will. Just so they're fresh columns. Now to find the uncertainty in velocity, delta V, and this will be also in centimeters per second. What we need to do is find the relative, or kind of like the percent uncertainty in distance. We're going to add it to the relative uncertainty in time, and then multiply by the velocity. I'll show you exactly what to type, and this will be true for you too. Since we're doing math, we type equals. And we're going to have an open bracket, and we're going to say the distance the magnet fell, so the uncertainty in distance divided by the actual distance. So it's always going to be 0.1 divided by 14.7. Then, with the uncertainty in time, this is different every single time, so I'm going to click on this. Divided by the actual time, click on that, close brackets, then time, which is like shift 8. I'm going to click on velocity and click enter. Then fill down, yes. It gives you too many decimal places. Uncertainty should only have 1 decimal place. So we have to click these buttons to get, or so 1 single figure, to get only 1 single figure. Now, uncertainty is the boss because this is a node, that's why it's just the ones. We also need to round off the velocity to match that. The uncertainty is the boss. You can remember that from what we also did in grade 9. Yes, I need to wrap the text. And I also need to center this column. Good. Now we're going to make a graph in Logger Pro. So we're going to have our independent variable. That is our current. Let's try that again. Double click X. Column definition. This is current. The symbol for current is I. Just trust me on that, please. And current measured in amps, and the symbol for amps is capital A. You're going to have something different here. Now our Y, again, we did measure the time, but the reason we measured the time was to actually get the velocity. Our dependent variable was our velocity. So we're going to need our velocity information here. And this will be velocity V, and our units are centimeters per second. Normally meters per second, but in this case you worked in centimeters per second, and that's okay. Now we only have to use a small part of the graph. Normally I like to auto scale from 0, but then all this area we didn't use. So in this case, just a general auto scale is good. There's a dot right in the corner, so I'm going to drag that down a little bit so it's not right in the top corner. We're going to add in our uncertainty for current. Let's look back and see what it was. It was plus or minus 0.01. Okay, so I'm going to double click on this. I'm going to come to options, error bar calculations, and 0.01. And then we get these little error bars. Normally we do little circles around the dots to show us where they are. Now that with error bars, we don't need those. I'm going to double click the graph. Click on graph options. I'm going to turn off point symbols because we don't need those little circles anymore because we have the error bars. Now the uncertainty in velocity, it's not just one number. We need to have a column. So what to do with this, we make this graph be a little smaller. And click here, make this table area a little bigger. And we're going to say data, new, manual column. We're going to call this uncertainty in velocity. The short name, the delta, they built it in here for us. Alpha, beta, something, I don't know, delta. And our units, again, are centimeters per second. And we're going to copy and paste in this uncertainty for velocity. Paste it in here. And nothing happened. So we need to do something. We're going to double click velocity, click on error bar, but instead of a constant, because it's a different number every time, remember it's 2, 2, 3, 2, 3, 2, 2, 1, it's different every time. We're going to use a column, and we're going to use it to use uncertainty and velocity, and it adds these, so it's 2, 2, 3, 2, 3, 2, 2, 1. So the uncertainty is different. You can also see by doing this that the relative uncertainty in velocity is pretty big, and the uncertainty in the current was small. Then we'll turn on our function. This could be a linear function, who knows? Let's try that. That's pretty reasonable. Notice, even though it missed the point, it goes through the error bar. This first one it misses, maybe because 0 is kind of a special case, but otherwise it matches the trend pretty well. Notice your graph will not be this shape for your experiment. Most likely your graph is for a different experiment, so it'll have a different shape. I hope it works out well for you. Any questions, please ask your teacher.